It's the end of the school year, kinda. So let's start this horribly cringy video. Hello. So, this is my half of the project that I'm doing with someone you all may know as Joe, aka Bruna. We decided to do guanine because it sounds like guava, and citizine because that's what guanine is bonded to. It's in DNA. Shall we begin this mess of a video? Let's talk about intermolecular forces. There are quite a few of them. Here are some, or all I don't know.
Dipole.
Oh my gosh, Taco, get out. Van der Waals forces, hydrogen bond, iron dipole forces, and London dispersion forces. We are gonna talk about hydrogen bonds today. Just to be clear, we are not talking about Italian DNA. That will remain as a mystery. Anyways, hydrogen bonds are found in DNA between the pairs. Guanine bonded to cytosine, and adenine bonded to thymine.
Can I be in the video yet?
Omar laminine for the 5683rd time. No. Sorry again. Let's continue. Hydrogen bonds are stronger than LDFs and dipole-dipole. But it ain't stronger than a network covalent bond. The definition of a hydrogen bond is an electrostatic blah 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 attraction. Basically it's a bond between hydrogen and a nitrogen, fluorine not flowering or oxygen. Again, it is an electrostatic attraction, not physical attraction. You might already have knowledge of a compound that exhibits hydrogen bonding. Dihydrogen monoxide. It's very dangerous. The chemical formula is H2O, also known as agua. You can't bring this liquid into airport speaker.
Finally, I get to be in the video. So, the structure of water. It has 2 hydrogens and 1 oxygen. When each individual molecule bonds with
Okay, so each individual H2O molecule that binds with another one has a hydrogen share electrons with the oxygen from another H2O molecule. Why? Because oxygen is more electronegative and it attracts the hydrogen atoms in a water molecule to share the electrons. How sweet. But then the oxygen decides to be a bully because it is more electronegative and it shares the electrons unequally.
Can I?
No. In water the boiling point is higher than some other compounds because the hydrogen bond affects it. So water plus a hydrogen bond equals a higher boiling point. Wow. It's the same for ammonia. But I don't feel like dealing with ammonia right now. Hydrogen bonds also have this weird thing where the bonds are longer in the crystal structure of water, which makes it less dense. It's the way the molecules are oriented. So about hydrogen bonds in general. Before I mentioned that most hydrogen bonds are between a hydrogen and either a fluorine, nitrogen, or oxygen. There are also other bonds where H and another element exist. But these bonds ain't strong. They are usually pretty weak. As long as a hydrogen is bonded to an N, O, or F, then it can be considered a strong hydrogen bond. Thank you for coming to my TED Talk.